Welcome to The Explainer. Today, we're going to tackle one of Go's most powerful and, let's be honest, sometimes confusing features, interfaces. If you can get these right, you're well on your way to writing some really clean, flexible, and truly idiomatic Go code. So it all really starts with this question, which gets right to the heart of Go's design philosophy. If you're coming from another language like Java or C++, you might be scratching your head, wondering, how does Go pull off this kind of flexibility without the big, complex class hierarchies you're used to? And the answer, it turns out, is just surprisingly simple and elegant. In Go, it's not about what a type is. It's all about what it can do. And it all comes down to a simple idea, a contract. Okay, so let's dig into that core idea, the interface as a contract. What in the world is an interface in Go anyway? At its most basic level, an interface is just a collection of method signatures. And look at the key phrase here. It specifies what a type can do, not what data it holds. It's purely about behavior. It's a to-do list, not a resume. Here's a great way to think about it. Imagine a job description. If you're hiring for a writer, the only thing you really care about is that they have the skill to write, right? It doesn't matter if the applicant is a file on your hard drive, a network connection, or even the command line. If it can perform that action, it gets the job. Go doesn't care about its background, only its abilities. And this right here is where Go's philosophy really starts to shine. In a lot of other languages, you have to explicitly stand up and say, hey, my class implements this interface. But in Go, it's automatic. If your type has the right methods, it satisfies the interface. That's it. This implicit, or duck typing nature, is what makes Go so incredibly flexible. So this whole idea of an implicit contract leads us to a very, very powerful tool. What if we need to write a function that can handle a value, but we have no idea what its type is going to be? Well, if an interface is a contract that lists required methods, what happens if that contract requires, well, 0 methods? It becomes a contract that every single type in Go satisfies automatically. This is what we call the empty interface, which now has a handy alias, any. The box analogy for this is just perfect. Think of a variable of type any as a generic container. You can put an integer in it, a string, a custom struct, literally anything at all. The box holds it just fine, but from the outside, all you know is that you have a box. You've kind of lost the specific information about what's inside. And yep, that's the trade-off. With great flexibility comes great responsibility. The compiler can't help you anymore. You can't just, add 2 any variables together because for all you know, they could be holding strings. So to do anything useful, you first have to safely check what's actually inside the box. So how do we peek inside that box safely? Well, Go gives us this fantastic tool called a type switch. It's the clean, idiomatic way to handle a value of type any. It checks the real type inside, and for each case, Go gives you a new variable, here v, that is guaranteed to be that specific type. So inside case int, v is an integer, and you can use it just like one, completely safely. All right, buckle up, because we're about to get into a concept that really separates junior and senior Go developers. This is a classic gotcha that comes up in technical interviews all the time, because it tests if you really understand how interfaces work under the hood. This one sentence right here is the key to everything. You have to remember that an interface variable isn't just one thing. It's a 2-part structure. And for that whole structure to be equal to nil, both of those internal parts have to be empty. Let's go back to our box analogy, but let's call it a gift box this time. For a gift box to be truly, completely empty, truly nil, it can't have a gift inside it, right? But also, it can't even have a gift tag on it, saying what kind of gift should be inside. If there's a tag, the box has a type, a purpose, and so it's not considered completely empty. So let's get precise. An interface holds 2 pieces of information, a type and a value. The nil trap happens when the type part is set, that's our gift tag, say for a star custom arrow pointer, but the value part itself is nil. So you've got a box with a tag on it, but there's no actual gift inside. And this is where it gets really mind-bending. You check your error variable with if error not equal to nil, and the result is true. So you're thinking, okay, I have an error. But then you go to print it, and it just prints nil. Why? Because the interface box itself isn't nil. It contains a type. It has a tag on it. But the value inside that box is nil. This is the trap. Your code thinks there's an error when for all intents and purposes, there isn't one. So remember this for your next interview. When they ask you, here's your answer. An interface is only nil when both its internal type and value are nil. A nil pointer still has a type, like *custom_error. And when you put that into an interface, the interface itself becomes non-nil because its type part is now filled. Okay, let's zoom out for a second. How do interfaces fit into Go's bigger design philosophy? Well, it all comes down to this core tenet, preferring composition over inheritance. See, instead of creating these big, deep family trees where a sports car is a car, Go encourages you to build types by just assembling them from smaller, independent pieces. A car simply has an engine. Now, embedding takes this a step further. It gives you this nice, convenient syntax where methods from an inner type get promoted to the outer one. So it looks a bit like inheritance. But don't be fooled, it's still composition under the hood. This helps you avoid a ton of problems that can plague classical inheritance.
All right, so knowing how interfaces work is one thing. Knowing how to design with them effectively, that's a whole other level. Let's cover the best practices that'll make your Go code clean, flexible, and just a joy to work with.
There are really 3 core principles that will guide you to great interface design in Go. Let's walk through each one, because they are absolutely fundamental to mastering the Go style. You've probably heard this before, but it's so true. The smaller the interface, the more powerful it is. Why? Because it's just so much easier for other types to satisfy it. Take the classic io.reader from the standard library. It just asks for a single read method. That's it. It doesn't care about anything else. And that makes it incredibly versatile, letting you write functions that work with files, network connections, or in-memory buffers without changing a single line of code. And this brings us to probably the most famous proverb in all of Go. When you're writing a function, be liberal in what you accept. Ask for an interface, just the minimum behavior you need. But be conservative in what you return. Give back a concrete struct. This gives the person using your function the full, real type to work with, and they can always choose to assign it to an interface variable if they want. It really is the best of both worlds. So there you have it. We've seen how a simple idea, a contract, can lead to these powerful, flexible systems. By focusing on behavior, you can build Go programs that are decoupled, easy to test, and easy to change. The only question left is, what are you going to build with that power? Thanks for joining us on The Explainer.